I'll go ahead and say in advance you'll want to have, if you're going to do this with me, which is the best way to kind of approach what I'm doing tonight, you'll want to have Canvas open and Replit as well, or Replit IT, however you call it. I call it Replit. Once the clock strikes 7:16, we will get started. Boom. All right, there we go. So good evening. Welcome to the live stream tonight, guys. We're doing the second half of Chapter 10 with JavaScript functions with the LaunchCode program. I'm a TF with the St. Louis cohort. It's going on right now. We're in week 3, I guess. For those who did not see the original live stream, the one we did last week, we did the first half, give or take, of Chapter 10, 10.1, 10.2, 10.3, 10.4. That video is on my channel, so you can check that out. And what we want to do is come back before Thursday and tackle as much as we can of the second half. Got a lot of positive feedback from the first video. Really appreciate that. Thanks for reaching out to me, those who did. Sounds like we got a lot of people got benefit out of it, that they actually helped a lot of people, so that's really awesome. I did get a few questions. Hey, are you going to do this for the remaining chapters? And the answer is probably not. For a few reasons. First of all, Terrence TF, or TF Terrence, he is already making some incredible JavaScript videos that walk through the chapter, and I'm not trying to duplicate efforts for any reason. I want every student should be going to those videos as a reference. They are fantastic, among the best that I've seen. And the reason I'm doing this here is really not so much to teach, but as to give the students in LaunchCode an example of how to approach the book. Right? How to approach the book as a learning tool. Because the feedback that I'm getting and noticing, interacting with different students, both from my group as well as other groups, is that to a certain degree, there may be some kind of treating it like an academic exercise. We're trying to just read everything and learn everything and commit it to memory. And then there's a little frustration when you get to the exercises or the studios, don't know where to start, don't really know which way to go. And so I said, hey, let me kind of just cosplay as a student. I'm going to start at the very beginning of Chapter 10 and just walk through it. Last week we did this. It took about 2.5 hours, which is normal. Even though I did a lot of breaking away, it's very normal, 2.5 hours there. Tonight we may do, hour and a half, 2 hours, we'll see. I just ate my ribs, leftovers, feeling a little full already, so might have to coffee up in a minute here. But what we're going to do, we're going to kind of walk through the beginning of Chapter 10 real quick. Then we'll pick up where we left off last week, which will start us at Chapter 10.5. And the whole idea behind this is that I'm a huge proponent when it comes to this LaunchCode stuff of active learning. Active learning when it comes to the book, the reading itself. And so for those who are watching right now, I see 3 of you. Rose is here. Hey, Rose. Layla's here. Hey, Layla, glad to have you. I think that's Rose, R. Livingston. Glad to have you. And guys, feel free to leave comments either in the comment box or on Slack, wherever you're more comfortable. But I'm a big proponent, and I say this over and over again, of active reading. Active reading. When you read the chapter, you want to have Replit open, and every time they give you a code snippet, every time they give you a little example, you'll want to go over to Replit and actually replicate that code right then. If you have to reference the book, that's perfectly fine. After you do that and you're comfortable with it, what you want to do is just erase Replit and then not log it back in, but try to do it again on your own. And what you find is you're going to get better at coding by coding more. It won't be by reading more. It won't be by taking volumes of notes, even though note taking is perfectly fine. I'm not trying to discourage anyone from that. But in terms of getting more comfortable actually coding and having the approaches you need to the exercises, it's probably going to be a lot better to be more invested in active coding and reading than trying to take tons and tons of notes or make flashcards or anything of that nature. So that's my suggestion. So that's what this is for people who may be having some struggles, having some challenges, and need a different approach. This is a different approach. And I haven't read any of Chapter 10 beyond what we did last week, so all of this will be fresh eyes to me. I'll probably make some mistakes. I'll stumble through some things, but you'll see the real live experience here as it happens. And what I'm challenging you to do is, if you are one of those who's having some challenges, having some struggles, things aren't clicking the way you want to, try my method. Try it for a solid week, from Monday to Monday or Thursday to Thursday, and see does it make a difference for you when it comes actual studio night. Because ideally what you want to happen, like tonight is Tuesday, by Thursday night, You want to make sure you have all the reading done and all the exercises done that are due or that are leading up towards what's going on for Thursday's lecture. And any questions you have, you're bugging STFs. Hey, I need help with this, need help with that. Can you help explain this concept? That kind of thing. Then when you get in the class on Thursday night, what Kyle presents should really be kind of rekindling what you already learned on your own in the process of reading and coding along. ABC, always be coding. It should be like a refresher and hopefully also adding some more color and depth to what you already read on your own in this blended learning model. So that's enough intro stuff at 7:21. Still have two people sticking around. Glad to have you. Everyone else, hopefully you'll get to see this in the later video. We're going to do the second half of chapter 10. And for the last time, if you did not see the first half, it is on my channel here in Coding Paths. So let's go. Chapter 10. So we did 10.1 through 10.4. I'm just going to breeze through this really, really fast. We'll pick up in earnest on section 10.5. So 10.1 was the intro. We talked about console.log, talked about how log is a function itself. With this dot notation, it's a function, it's a method of the console class. We actually dug in, looked at the MDM documentation last week about the other methods that are available to you as a programmer for the console class. We talked about these functions, number, string, and Boolean, these type conversion functions that are built into JavaScript. We talked a lot about things that are built into JavaScript for your behalf. We talked about string and array methods. Of course, string is a class in JavaScript, and you have the array class or object. And these objects have properties and methods, and one of them is index of. So we went through all of that together. We went through the examples. I'll say for anybody who did not see the other video that I made, the big thing I like to emphasize is every time you see an example, something should trigger in your mind Replit. Like code it right then. Whatever examples they give you, code it right then. So we went through using functions, function calls, function invocation. We went through all that. We went through the arguments. We talked about that in depth. We went through creating functions together, 10.3. We talked about the difference between parameters and arguments. So following the function name, we define the parameters within those parentheses. Those are kind of like the variables, where the arguments were more like the value. So when you're defining your function, these are actually parameters right here. We call that the more generic or the more abstract form, the variable form. When we invoke that function, when we call that function later, the values we put in those parentheses, those are the arguments. So that's the difference there. So we talked through 10.3 last time. We went through these examples. We kind of mixed them up a little bit. Another thing I encourage you as a student to do when you get a small code snippet like this, code it yourself in Replit. Once it works and you feel comfortable with it, you can do it on your own. Mix things up, change things around. See, can you break the code? See what kind of error messages you can create. Because this is a sandbox environment. I like to compare this whole process like playing with Legos. And you just want to take this block and see what you can make and turn it upside down and flip it around. That will help your learning a whole lot. So we went through this example and all the examples in 10.3, doing some basic iterations here through a list of names in an array. Talked about defining the function, where you actually put the body of the function in its name with any parameters if needed, and then later on calling the function. And of course, we learned the other way we can refer to calling a function is invoking a function. Went through all that. We got to 10.4. I think this is where I got really bogged down. Like this page right here alone took a long time. But again, I'm doing this like a student. I'm kind of in the student role right now. So 2.5 hours for that much is pretty normal. If it takes you 2.5 hours to go through that, that would be pretty normal. Then you put in another hour and a half, 2 hours in on the second part. I'm thinking in terms of the hours expectation that LaunchCode gave you when you started. That would be about normal. So nothing's been too off so far. But we talked about the function machine. We talked about thinking in terms of inputs and outputs, returning a value. We looked at that together. We looked at the fact that using return is actually optional. And there's an implicit definition of undefined when you do not use that return statement explicitly. And so we did the console.log of what this was here, the return val. Since we didn't have the return statement, it just returned undefined. So we looked at that together. Talked about the fact that return statement will actually terminate execution. And it doesn't terminate execution of the entire program. It terminates execution of that function, right? So in this case right here, we looked at the fact that once you get to return I'm done, it will exit JavaScript, the running of the program, the runtime, will exit out of this function and then go down to console.log, which means this console.log will never be seen. JavaScript will never even see that because of the return statement. Return terminates execution. We went through these. We went through Boolean functions. We spent a lot of time on Boolean functions. If you have no clue what these are, again, feel free to go to the video and check that out. We went through parameters and arguments once again. Parameter will be this value, right? Or this is the parameter when you go to the function definition, and then when you actually invoke it later, that will be the argument. So the name in this case is the parameter. Lamar is the argument. Talked about that a lot. Arguments are optional. We talked about that, which means the next thing should be what you could do to, I think there was one that said you can use default values. Yeah, right here. So we used some default values when it came to this one. Yeah. So in this case, if there's nothing put in for name as an argument, then it defaults to world, which means if we put in hello Lamar, it'll print hello Lamar. If we put hello with nothing as an argument, we have a default here. That's how you do defaults on your functions, and it'll assign name to be world. And that was the end of few check understandings, and that was the end of 10.4. So tonight, we'll begin with 10.5. I'm walking through it step by step as if I was a student, never seen it before. Just real quick, let me just check the stream. We have 4 viewers. Glad to have you. Isaac is in the house. Now, Isaac, what are you doing? We got TFs in here. Oh my gosh, it's all over. Welcome, Isaac. We're doing a live stream tonight, just walking through the entire chapter 10. Actually, the second half of chapter 10. Isaac's an amazing developer here in the Memphis area. Good friend. GDG, Google Developer Group leader here in the Memphis area. Salesforce God. Like, he's just a lot of things. So that's my dude. But yeah, I'm just kind of showing them, Isaac, how to approach these chapters, that they shouldn't just read it, and then try to do the stuff in the back of the book. It'll be a lot better for them to read, do an exercise, read, do some exercises, things like that. And last time I say this, anybody has a question, drop it in the comments or in Slack. That being said, let's go 10.5. A good function writing process. So the function is the most complex JavaScript that we construct that we have seen. Again, if you're following along, you should have your Slack open, your Canvas open, and your Replit open, repl.it. So the function is the most complex JavaScript construct that we've seen. Functions have more components to their syntax than just conditionals or loops, and they can be used in more intricate ways than those constructs. To avoid frustration, and bugs, it's important to approach writing functions in an intentional, structured way. This is essential as you start to write more complex functions. In this section, 10.5, we will outline what we think is the best approach. To provide concrete examples, we will consider a fictional function that is able to make a sandwich. Scared of that function. Step 1, 10.5.1, design your function. Before you put your fingers to the keyboard, it is important to have a clear idea of what you want your function to do. So they're saying before you code it, you need to think this thing through. You should ask yourself the following questions. What data does my function need to do its job? Should my function return a value? What should be the data type of my function's return value? Exceptionally important with statically typed languages. What is a good descriptive name for my function? What data types do we expect the parameters to be? What are some good names for my parameters? So for our sandwich function, for instance, they said the specifications will be, the parameters will be bread. That makes sense. Filling and condiments. Okay. Return value will be the finished sandwich. And so this is using the model of the function machine where we have inputs and outputs. So we have inputs of bread, filling, and condiments. Output, what we're returning, what we're producing at the end of the day, will be a finished sandwich. The return type is an object of the type sandwich. We've talked about objects for a while now. Strings being objects, arrays being objects, console being an object. So we're going to have an object of the type sandwich, but we're going to make a specific sandwich. The function name, make sandwich, makes a lot of sense to me because we don't code just for ourselves, we code for others as well. So making descriptive function names is literally as important, if not more important than comments. With lines and lines of this function does this. If I give a function name to you called make sandwich, you probably know what it is already. And last but not least, the parameter names and types. So bread is a string, filling type is a string, condiments, plural, is going to be a list of some type. So let's go with an array of strings. Note, JavaScript does not actually have a sandwich data type. I think you knew that, but if you didn't, there it is. We want our function to be as flexible as possible. For now, recognize that returning a simple string to describe the sandwich will not be useful. In later lessons, we'll learn how to create custom data types, so making a virtual code-based sandwich here is not a problem. We're now on 10.5.2, step 2, create the basic structure. Now it's time to start coding, which means, well, we haven't seen an example yet. We should see an example in just a minute. Now it's time to start coding. Using the design decisions you just made, write the minimal syntax needed to create the function. Here's what an outline of our sandwich function would look like. Function, make sandwich, and the 3 parameters, bread type, filling type, and condiments. Now this is where you as a student, so I'm breaking away from the book now, this is where you from a student have to stop reading. And I know the impulse is you just want to get through the chapter so you have the reading done. You want to just read. And I'm saying, when you get a little code snippet like this, blow the whistle, time out. Right there, open Replit and make sure you can just code just what's there. And it's literally one line with the extras, with the closing curly brace. So we should be able to do this pretty easy. Do it along with me, not only for this chapter, but all the remaining chapters. Let's go to Replit. So Replit comes up like this. Checking for any questions. Thank you for this. You're most welcome, Makia. I hope, is it Makia or Makaya? I'm sorry. But thank you. You're most welcome for this. Be sure to let anybody know who's struggling with this stuff to go ahead and join us. Like I said, I'm going to try to record it, but I'm not just a pro streamer. So we'll see how that works. I'm streaming now, but like recording it and putting it up later, we'll see what happens. It worked last week, so part 1 is available. As far as tonight, yeah, we'll see. But anyway, glad to have you. So we're going to go to Replit. You should be doing this along with me. Everybody out there, we're going to go to Node.js. We're going to create a Replit. We don't care about the name of this thing. Boom. We have an online editor ready to roll once my internet cooperates. Boom. We're ready to go. Let's make sure we're all connected here. Console.log, hello students. You got to put the exclamation point because they always do it in the book, right? Anyway. Run that right quick, looking good, awesome. So what we're supposed to do is create the basic structure of a function called make sandwich with 3 parameters, bread type, filling type, and condiments. So this is where you go over here and just see, can you do it on your own? If you can do it on your own here, it will sync in your memory, it'll be part of your muscle memory, and when you get to the exercises at the end of the chapter, they'll be a lot easier, promise. So it went something like what? Function, which is our keyword, make sandwich, which is what they named it, and then we have parentheses and our curly braces. They didn't give us a body yet, but they did give us 3 parameters. One was bread, I think. Was it bread? I don't know. Let's look. One was bread type, filling type, and condiments. Cool. So bread, can't spell, bread type, filling type, and condiments. Done. If I run this, what's going to happen right now? If I run this right here, what's going to happen? Absolutely nothing. For 2 reasons. What are the 2 reasons nothing's going to happen right now? Good. Number 1, there's no body. The body would be inside these 2 curly brackets, that one and this one. There is no body. And also, we've never called the function. We only defined it. We defined what it should do, but we didn't tell it to do it. And if you were on the stream last week, or if you watched the video, you know I said this is like good Fido. This is a good dog. He knows what to do, but until you tell him to do it, he just sits there. Like you may have taught him how to roll over. Let's just pretend this is Fido rolling over. But until you say Fido roll over, he doesn't do it. So your functions work in a similar manner. They may have all the descriptions. It might be a 1-line body. It might be a 100-line body. But they have all the descriptions of what to do. But they don't do anything besides being saved in memory until you call or invoke that function. So right now running this does absolutely nothing. But we as students know we're comfortable with how to write a function. Now that was super simple, and I'm not trying to dumb it down for you, but I'm telling you, coding each one of these little snippets of code that they give you in the book will help it all make a lot more sense than trying to just cram a bunch of facts in your head and, you know, produce some result later. Code along with the book, code along with the book. All right, here we go. 10.5.2, we did that. We're good to go. 10.5.3, let's make the body, write the body. With a basic structure in place, go ahead and start writing the function body. Be sure to alternate between subtasks and running your code. Do not wait until you've written the entire function body before testing your code. We can't emphasize this enough. Going long stretches of time without running the program is a good way to end up frustrated. Interesting. I would add a parallel to that. Going long stretches of time reading the book and not coding anything is a good way to end up frustrated. So I'm just going to tag along with them because they have a very good point here that you should be coding and testing, and don't go long stretches without testing your program by running it. Recall in the chapter on debugging that we made the following recommendation to avoid bugs. Get something working and keep it working. Very good recommendation. This applies especially to writing functions. Every good professional programmer works in this way. Write a few lines of code, run it, debugging errors, and repeat. Following these steps won't prevent you from making mistakes, but it will reduce the number of bugs you create. This helps you more quickly produce solid working code. All right, cool. So it says, with this structure in place, go ahead and start writing the function body. Bread type is a string, filling type is a string, condiments is an array. Not a whole lot of things we want to do here. If we're given those things, we can, just as a test, we can just console log them out. And we can use string concatenation for the moment. So this bread, this sandwich is made of, we get out of there. No, we're not going to do concatenation. Take that back. Let's go ahead and use our template literals. Why not? So console.log, tick mark, which is over there by the number 1. This sandwich is made of, we're just making this up on the fly. It doesn't really matter at this point. We're just getting comfortable doing simple things in code. So this sandwich is made up of $ curly bracket bread type, comma space filling type, whoops, $curly filling type, and $curly condiments. Why is that green? Where are you, green condiments? Something's off. This sandwich is made of, you guys see it? Brioche is a superior bread. Oh, brie. Yes. The sandwich is made up of $squiggly bread type, comma, $squiggly filling type, comma, and $squiggly condiments. That is odd. Why is it green? I'm missing something. Which means we can now call our sandwich method and put in some parameters or arguments. Which one is it? Which one's up here? Parameters. Which one goes down here? Arguments. And we said those are going to be string, and array. I'm just going to do 3 strings for the moment. So bread type, we have a nice recommendation here. Let me copy and paste that. Thank you, Isaac. Super simple function. You can't get more simple than this. Which means this is the kind of thing you can do. Filling, we're going to do a good old bologna sandwich. Why not? This is an array of strings. I'm just going to put a single string for the moment. We're going to give it some mayo. I'm not liking that green on the condiments. It tells me something is wrong, but it worked. It worked perfectly. Is it because it's just the second line? No idea, but it worked out perfectly fine. So this sandwich is made up of, what did I type? Yeah, brie, bologna, and mayo. Why can't I read that better? There we go. It input each one of the variable values in for the variables right here. We're good to go. We're making a sandwich. We're at the end of 10.5, on to 10.6. Any questions so far? Did you hit enter in the line break between? I might have hit enter. That could be it. Thank you, Isaac. Appreciate that. That exactly could be it. Any questions? I don't see any questions in Slack. Don't see any questions in YouTube. Let's keep it moving. If you do have a question, just drop them in there. 10.6, parameters and variables. Earlier, we said that a parameter behaves like a variable that exists only within the function. While this is true, the relationship between variables and parameters is actually a bit more complicated, of course, because why keep it simple? Function scope. The scope of a variable is the extent to which a variable is visible within a program. Now that's one of those sentences that when you're a student, if you don't have any programming experience, you read it and it makes no sense at all. Like, what are they talking about? This is Greek, this is Mandarin Chinese, this is hieroglyphics spoken. What are y'all talking about? And this is where I want to encourage you when you come across a sentence or even a word or a phrase that doesn't make sense. Yes, Google it, see if you can get some understanding, but if you don't just rush past that and think maybe it'll make sense later. Please go ahead and ask your TF right there on the spot. Hey, what does this mean? I'm not understanding this concept. I Googled it. The examples didn't even make sense. And more than likely, your TF will get with you within the next 24 hours or so. But what they're saying is the scope of a variable. So that's going to be a new phrase for a scope. It is the extent that the variable is visible. So the block of code where that variable can be seen, that's a scope, which implies there may be another block or blocks of code where that variable is not seen. We will say that area is out of scope. So you have in scope, out of scope. In scope is visible. We can see the variable. We know what it is. We're not going to get a undefined error or a reference error. We're in scope. Out of scope means it's invisible. You name the variable over here, but this block of code, because of the way the program is structured, it has no idea what that variable is, and it gives you all these errors, and you're calling me. So here's how to avoid that. Scope consists of all locations within a program where a variable can be used or modified. Introducing functions gives us one of our first examples of limited variable scope, a situation in which a variable is not visible throughout an entire program. In particular, a variable defined using let. So we talked about var const let. We're fans of constant let. If you define a variable using let within a function, it is not visible outside of that function. Let that sink in for like 10 seconds. If we define a variable using let inside a function, that variable is not visible outside of that function. So you understand that. They give us an example here, but as a student, if I was a student right here and I'm approaching this as a student, right there I would start coding because I understand that sentence. A variable defined using let within a function is not visible outside the function. And as a student, I would just want to test it, literally. So here's a function. Let me give my semicolon here. And I'm going to just test it. So they said if you do let, so let satisfied equal true, because we're going to be satisfied with a sandwich. So we're going to call the function, and then we're going to console.log satisfied. According to the book, this should give me some sort of a blown up error, house on fire situation, because it said if you define a variable with let inside a function, and that's what we did, it will not be, how do they say it? It will not be visible outside of the function. And this is clearly outside. Let's test it. Are you ready? Let's go. Whoa! We blew it up. I'm so excited to see this. I would love all of you to get a similar or different error. Break the program on purpose, because then you get to debug without any pressure. Like you're not being paid for this yet. We can debug without pressure, and we can learn that we have a reference error, and the reference is satisfied is what? Not defined. Well, what line is this on? What line is going wrong? Right here. Line 9. Boom. Exactly what we thought would happen is what happened. And the benefit is we get more comfortable with error messages. Error messages shouldn't scare you like, oh, nothing's working. Like, even though that's the first inclination, like I said, we want to just take this as an example of how to read and break down the errors and see how to use them for our benefit for debugging. So this is telling us very explicitly that it has no idea what satisfied is, even though we used it in line 9, which means in order to fix that, let's just try something. Let's just try const. I don't know if this will work or not, but this is how I want you to think about this. Don't think about it like the book is just so, etched in stone. I have to follow everything. Take the basic format of the examples and then just play with it. Flip stuff around. So let doesn't work. Does const work? Does const work? Const did not work either. Interesting. Still not satisfied. Back to the book. Any questions so far? No questions there. No questions in Slack. Let's keep going. So this function takes a string and returns the result of removing all hyphens from the string. Awesome. So we have a function. We're going to just do this right here. We're going to copy it, Control C, go to our replit, Control V. Let me just go up here. I don't know why I have all that extra space. And let's just look at it together. So they claim, the book claims that this function takes a string, so that's the input, it takes a string, and it returns, it produces as a result, the output is a string that has all the hyphens removed. Let's see if we can see that in the code. All right, function, there's our keyword. Name of the function is remove hyphens, and the input will be the abstract value or the abstract parameter, str, for string. All right, cool so far. So this thing is going to take in a string. We have a let, interesting, let string without hyphens or str without hyphens equal a blank. Now what is, so right, without even going any further, we're starting with a blank string. I want my semicolon. We're doing some iteration here. We're stepping through with a for loop and we're adding. There's some adding right there. We're going to look deeper into this, but just right off the bat, what kind of pattern is this? Because we've seen it a few times now. I think they're kind of being repetitive with it for a reason. We start with an empty bucket called string without hyphens, and we gradually fill that bucket up over time through iteration. What is that called? And the answer is the accumulator pattern. Again, feel free to drop a comment down in the comments or in Slack. That's the accumulator pattern. So for I equals 0, so we're going to start at 0. Why are we starting at 0 so often with these strings? So like every time we have a string and we have some kind of iteration, they start with 0. Why not start with 1 or 3 or x? Why is it I equals 0? Besides the book said so. Because the index first value, just like the index of the first value in an array, is 0. So if our intention as a programmer is to start at the beginning and to iterate, to step our way through that string, you're going to typically start with 0 and go to the length as the ending value for that iteration. And each time we do this loop, we're going to add 1 to our I. So that's kind of standard. You should be used to that by now. And within this for, we have an if. So we have an embedded if. And it says if the character at that position of string bracket I. So the first time it'll be string bracket 0, which is whatever the first letter is. I guess if it's LaunchCode, it'll be the 3. The next one will be 1, etc. If that character does not equal a dash, are you with me? If the character we grab is not exactly equal to a dash, then string without hyphens, which is our empty string up here, we're going to add that character to it. So you see what they're doing? We're starting with one string that has the parameter name of str. It's kind of like its variable. We're starting with that string. That's going to be our input string. And we're going to just walk through it. We're going to iterate through it, starting at the what? The first index and going to the end. And the way they define this is if either one of those characters, if they are not a dash, then add that character to this other string we created called string without hyphens, an empty string, an empty bucket. So it starts with the 3. It's not a hyphen, so it adds it. 1, it's not a hyphen, it adds it. 4, it's not a hyphen, it adds it. Then we come to the hyphen, it does not add it. It just goes to the next one. That's what the iteration does. That's what this right here does for us. It just keeps iterating through. And so we're going to console.log the result, the returned value, because we're returning the final string right here. We're going to console.log that result by calling the function name, and then they put the argument in here that's equal to that string. This is not a number, even though it's numbers, it's not a number in terms of data type because it's in the quotes. So they console.log that. They also console.log the final string right here. That should be the same thing, right? Reference error. String without hyphens is not defined. str without hyphens. Oh, very interesting. str without hyphens is not defined. So that's very interesting. they're doing two concepts at once, and that's fine. So we got the correct value here, but then when we reference the variable, because that variable was assigned with a let, we just read that if you assign it with a let, it's not visible outside the scope of the function. So this console statement can't even see that variable. This console statement doesn't have to because it only sees the function. So this is a result of running the function directly. Stay with me. This, what you see, let's just comment this out. This here is a result of running the function. And within that function, we have the variable, the iteration, we have the whole shebang. Okay? That's why there's no error. But this guy, this little guy right here, is trying to just print the variable. But we just learned together that if you assign the variable name to using a let within a function, it is completely invisible outside the function. So when I run that one more time, it runs successfully here by running the function. Then we get ugly error messages here because we're trying to reference that variable directly that we can't do. It is invisible. And I'm sure that's what they say all through here. So 10.6, check for questions. Don't see any questions there. Don't see any questions in Slack. I'm going to keep going. 10.6, the last line of this program tries to print the variable str without hyphens to the console, resulting in an error. I just said that. The previous line calls remove hyphens. It calls the function remove hyphens, at the end of which str without hyphens has the value 314.254.0107. However, once the function finishes execution on all variables and parameters within the function are destroyed. Let me read that again slower. Once the function finishes execution, all the variables, all the parameters within the function are destroyed. So as that function is running, all the variables and parameters it needs, it has it at its disposal, so it can properly run. This says when the function is finishing execution, and we know it's finished when it hits this return statement, right? Once that return statement is executed, the variables and the parameters that it did know, completely destroyed. It's like, I don't know you anymore. Like, we're not friends. But out of my life. And it's literally, it's removed from memory from the JavaScript program, which is pretty neat. That is what we mean by scope. A variable is not necessarily usable throughout an entire program. Where it can be used depends on the context in which it is defined. The context in which it is defined, period. For variables and parameters within a function, their scope is known as, you guessed it, function scope. I'm going to read that twice. For variables and parameters within a function, what do they mean within a function? Within the curly braces of the function body. Within the function, those are known as function scope, which means they are only visible within the function in which they are defined. All right, I really drove that one home. Let's keep moving. 10.6.2, hope you're still with me, variable shadowing. We just learned that variables and parameters defined within a function are not visible outside that function. The opposite is more complicated. A variable defined outside a function may be visible within the function in certain circumstances. And if you're hearing a lot of wishy-washy uncertainty, you're right. You're absolutely right. Anyway, yeah, JavaScript. Get used to it. But yeah, certain circumstances, it may be visible inside the function, which means certain circumstances, it may not be visible inside the function. Here's our example. Again, I'm not even going to read what they say. We'll come back to what they say. Let's just copy this and think it through. This is what I would want you to do as a student. I'm going to get rid of all that. Paste what they have, and let's see. So we have a variable called message. It is clearly a string. We know that from the quotation marks. It is defined using the keyword let. So there's that let again, but the let is not inside the function. We have a function called print message that's going to console.log whatever message is. So there's no parameters, but we are referring to that variable inside the function. And then we invoke or call the function right here. Excuse me. So one of two things is going to happen. Either this function can see message and it will print, or it can't see message and it won't print. Now, I know they tell us which one's going to happen in the book, but I want you to get used to just running it and seeing what happens. Many times I'm reading questions during lecture, people asking Kyle, that are really, really good questions. They're great questions. And the best way to answer them would be to just run those questions in your own Replit. You have access to a sandbox where lots of your questions, you can get answers on your own. For instance, hey, what happens if you assign a variable with let outside the function and then reference that variable inside the function? What happens? Well, you could ask that question. It's perfectly within your right to ask that question. And you can just try it. So let's just try it, see what happens. And it did work. Bingo. So now we know the answer to the question. The question being, if you define a variable, at least specifically to a string, for sure, outside of a function, and you reference that variable within the function, and you defined it using the keyword let, the function does see, it is visible to that variable. And when you invoke the function later, you don't get any ugly error messages. Question answered. 5 viewers, welcome all. Good evening, glad to have you. So, console output, hello world. Even though the message is defined outside the function, right here, it is still visible within the function. When print message is called, console.log message executes, message has the value hello world, so that the value is printed to the console. This means the scope of the message extends to the function print message. The scope of the message, okay, that variable extends into the function, which is called print message in this case. Warning, it is not the case that all variables defined outside a function are visible within every function. That is not the case. The reality is a bit more nuanced than this and will be explored in depth in a later chapter. I love when that say that. Like, don't get, too happy with this because we're going to just completely mess it up later on. But just know for now, it's not always the case that all variables defined outside of a function can be seen or visible within a function. That is not the case. There is, however, a specific type of variable, super variable, I just made that up, that is visible to every function, and that is known as a global variable. So we've learned about two different ones, right? We learned about function scope, and that's where a variable within a function has scope within that function. That's function scope. And now we're learning about global variables, where variables are visible to every function in the program. We remarked earlier that a global variable is created when initializing a variable without using let, const, or var, and they should be used very rarely, both for semantics, for best practice, and security purposes. This is very rarely that should be used. Try it. So, as you know, and I think we have maybe one brand new person join the stream. Glad to have you. Feel free to say hi, either in the comments or over in Slack. We're doing a stepping through chapter 10, the second half. And for those that have been around, you know that I don't even worry about when it says try it. I want you to try all these examples, all of them. That's what's going to help the coding to sink in for you. So don't wait for them to say try it to try it. Try all the snippets, all the code snippets, all the examples. However, they said try it, so we'll try this one too. What is the output of the following program? Form a hypothesis for yourself before running it. Once you've answered that question, try relocating the message to other locations. See how it affects the program. You might try placing it within or after the print message function. So let's go. Copying this right here. And we're going to paste it right here. All right. So we have let message equal hello world. It's not like we've seen this already. We have a function called print message that refers to that. I'm fairly certain that is going to print when we call it. So when we call or invoke the function right here, that should print just fine. Looks like we're changing message to mean goodbye. And then we're going to print message again. Ooh, this is a good one. I would love to see some input. Try it. You mean break it? Yes! I mean break it. That's exactly what I mean, Isaac. Break the function. Just break it all. Put it on fire. Infinite loops. Interesting. What do you guys think will happen? I would love to see some interaction. Feel free to, you can chat with me in study sessions on Slack or here in the comments on YouTube. What's going to happen? Message is defined here with a let. It's not a const, it's a let. We have a function name here. We have the function invocation here. I'm pretty sure, I'm pretty confident, hopefully you are too, that right here is going to print hello world. But then we attempt to change message to goodbye. What will it print down here? It's going to be either nothing, goodbye, hello world, or an error. That's the only choices I can think of. Which one and why? So let's run it and find out. And it actually changed it. So we looked at this much earlier. We did that already, so we kind of knew that was going to work. The question was, will it interpret this properly and will message actually be changed? And it is. So apparently we're dealing with something that is, in this case, of global scope. The variable is seen inside the function. And they said they wanted you to change it up and move it. So, let me see. Crap, where do they say it? I'm sorry. That's not it. That's not it. Here. For example, try placing it within or after print message. The declaring message. Placing it within or after print message. All right, so let's take this, break it, as Isaac said, I don't mind. Let's put it there, see what happens. What do you think will happen? Will it still do hello world, goodbye, or hello world, goodbye, goodbye? Or will we just blow the whole thing up? Let's see. Hello world, hello world. Why? Why was that hello world, hello world? I think it will ping hello world first, then goodbye. Look who's in the house, JC Smiley, my mentor. There's my TA. I'm you guys' TA, there's my TA. Two hello worlds. Why did it do two hello world? LaunchCode St. Louis students, why did it do that? Let me see you typing. Why not hello world, goodbye again? Well, what happens? Let's go through line execution. JavaScript gets started. It sees a function. What does it do? Absolutely nothing. It just remembers this sequence of steps is assigned to the variable print message. That's all it does. We call the function here, which means it goes up here. It runs the steps. Boom, boom, prints it out, hello world. Message is changed to goodbye here, but then when we run it, it's redefined again inside the function. So this one, it sees it, but it really has no effect because once we get inside that function, it changes it right back to hello world, which is why we got two hello worlds. Hello world. Awesome. Thank you. 5 viewers. Glad to have you. Let's keep it moving. Interesting thing happens. Blah, 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 blah. Cool. While the variable message declared on line 1 is technically visible within print message, it is in scope. It is hidden by the function parameter of the same name, which means when print message goodbye is called and console. Oh, this is a new example. I'm sorry. Going too fast. Slow down, Kimosabe. This is a new one. New example. All right, here we have let message equal hello world. We've seen it before. We have function print message with the message. Console.log that message. Interesting. And then print message goodbye. Oh, they're really trying to mess with you. So which one's going to print here? Hello world or goodbye, and why? What is going to print here? We've got it defined up here. We've got it invoking the function here with an argument. Which one is it going to print? The hello world or the goodbye? And why? I say it's going to print the goodbye because when we invoke the function is looking for a variable input, is looking for a parameter. And we give it that parameter in the form of this argument. So all it knows to do is use that argument. This is of little to no effect. So I'm looking for goodbye. And if it says hello world, I quit. I'm just kidding. Goodbye. All right, we're good to go. That's what we expect. Hope that made sense. So back to the example. When the variable message declared on line 1 is visible, it is hidden by the function parameter of the same name. Just said that. When print message goodbye is called, console.log message executes. Message has the value of goodbye, which is the argument passed into the function right here. Boom, right there. All right, this phenomenon is called shadowing, based on the metaphor that a function parameter casts its shadow over a variable of the same name, effectively hiding it. Now, that being said, there is no good reason to intentionally use variable shadowing in your program. In fact, doing so can lead to a lot of confusion over which of the two variables will be used in a given situation. So for that reason, you should avoid naming variables and function parameters the same name. How could they have avoided that? They could say, let greeting equal hello world. And we can console.log message, and we can also console.log the greeting. And you probably want to say hi before you say bye, depending on your culture. So let's just do that. And we can get access to both of them. Cool? I see no questions. Let's keep it moving. Number 10.63, check your understanding. What does the following code output? Let num equal 42, function, keyword, is even, function name, parameter num, will be return whether or not num modulus 2 is exactly equal to 0. So this is a what kind of function? We went over this last week. This is a Boolean function. We want to return if this is true or not. And so console.log is even 43, better return false. However, let's look at real closely. Let's copy this and put it in a replit. Let's not just look at it. Let's copy it, put it over here, and then test it. Num is 42. Is even takes in the parameter of parameter of num, which in this case will be 43. And 43 will get passed, which means 43 modulus 2 is not 0. So I'm saying it's false. If there's anyone who thinks it'll be true, speak now or forever hold your peace. I think it'll be false because we're taking in 43 as our input to our function machine. I say it's going to be false. Whew, I can keep my job. All right, cool. Hopefully everybody understood that. Let's keep it moving. We're on 10.7. Naming functions. This should be pretty easy. As with variables, choosing a good descriptive name for the functions you write is important. It makes your code more readable, therefore more maintainable and more bug resistant. Use camel case. We talked about this last week. As with variables, use camel case for your functions. All functions in JavaScript should begin with a lowercase letter, the first letter of subsequent words capitalized. So these are good examples. Astronaut count, field temp Celsius is ready. Also, as I mentioned last week, get used to all the astronaut and space references. They're not going away anytime soon. Just saying. Bad examples. Astronaut count. What's wrong with this one? Capital A. We don't like it. What's wrong with this one? Field temp Celsius. T and the C are still lowercase. We don't like that. What's wrong with this one? Is ready. Same thing. The R is lowercase. We don't like it. Now, when I say we don't like it, that's the difference between we don't like it and it won't work. Because if we just go let is ready equal false, and I say, hey, we don't like that variable name, that doesn't mean it's not going to work. What it means is we've broke the convention of what we expect. It worked, but that's not a best practice for JavaScript. And again, whereas you code not only for yourself, but you code for others, they're not going to be looking for all lowercase, if you have multiple words in the variable name, all lowercase variable names, all lowercase function names. They're going to be looking, if it's JavaScript, for camel case. So you want to follow the convention, follow the best practice. And there's lots of them that we'll pick up along the way. This is just one. Use verb-noun pairs when applicable. So a function carries out an action, often it produces some specific output or effect. We know that we can definitely get an explicit output with the return keyword. Therefore, using a verb-noun pair can go a long way toward making it clear what a function does. A good verb can describe the action. A good noun can describe the output or the object being affected. So, for instance, prepare for liftoff, fill fuel tank, get countdown status, etc. These are good examples. Just liftoff as a function name, probably not so much. Fill up, countdown status, not really. Is ready, I'm almost okay with is ready, but it's ready for what? And that's where they get a little more descriptive here. So even without comments, just a very well-constructed function name can help the readability of your code. And good code needs to be clean, readable code. So good function names are helpful. Don't discount that. If you go ahead and follow the best practice now, when it doesn't count, it'll be easy to do later down the line when it does count. As we noted earlier, for Boolean functions, it's conventional that their names start with a is or a has, like is ready or has fuel, something of that nature, whenever possible. Creating a verb-noun pair for a function does not always make sense. But when it does, you should use this format to create a good descriptive name. 10.7.3, using descriptive names. We've repeatedly reminded you. I got a message. All right. We have repeatedly reminded you to use descriptive names, but now we want to expand on this point. You should prefer long descriptive names over short abbreviated names. That's a little challenging for me. I think I tend to be a little less verbose. I like things just kind of short and compact in all cases. And what they're telling us here is you should actually prefer, when it comes to function names, long descriptive names. If you can read a function name and understand what it does from the name alone, that's a good name. I'm going to say that again for effect. If you can read a function name and understand what it does from just the name alone, that's a good function name. Like convert Celsius to Fahrenheit. Is there any question about what that does? Update mission control. Still slightly ambiguous, but we do have at least a direction of what's going on. Versus MSG to MC. Now that's me right there. I would use that in a minute, but that is bad practice. So we are not going to do that anymore. We're going to use the longer version because we don't write only for ourselves. We write for others as well. If you find yourself writing a comment to describe what your function does, consider whether a better name might remove the need for such additional explanation. I just said that. The best function and variable names are those that are self-documenting, descriptive enough not to need further explanation. Using self-documentation means that the code that uses your function will be more readable, since your explanatory comments are not visible where the function is used. Additionally, it's easy for comments to become inaccurate when you update your code to change behavior. There's nothing forcing you to also update your comments. Very good point. For this reason, some programmers live by the maxim, comments lie. While we won't go so far as to say that you should never use comments, we do believe comments should not be used to make up for poor function and poor variable names. Well, that makes sense. I'll buy that. Don't see any questions. We're going to keep it moving. Check your understanding. What is the best name for the following function? Function myfunc. That's so Lawrence. Just myfunc. Just throw it in there and keep moving. It'll work, but that's not what they're advising us to do. So function myfunc takes in a radius as a what? That's the parameter or the argument right here. That is the parameter. We have an area that's defined using the let keyword. It is equal to the pi constant times the radius, which is the input, raised to the second power. So area equals pi r squared. And return the area. So what would be a good function name? Area, circle, shape, or calculate area of circle? I think that one's probably the most obvious answer out of everything we've looked at so far. Calculate area of circle is very intuitive. We're on to 10.8. We're rolling. I'm not even sure how many we are tonight, but we're doing great. We've done lots of examples. Yeah, descriptive names only, also me, your I too, your I, me, your sample. Yes, exactly. And for perpetuity, let me just drop a comment in here myself. Exactly. But we're going to follow best practices. We're going to practice what we preach and all that kind of good stuff. Me and my 5 viewers, I'm glad to have you. We're on 10.8 in the LaunchCode JavaScript curriculum. I am stepping through it from beginning to the end as if I'm a student, emphasizing the need for active reading. We're not going to just read. We're going to read until we get to some code. When we get to some code, we're dropping it in Replit. Let's go. 10.8. I need water. Yes, it's water, Isaac, before you ask. All right. The practice of using functions to build other functions is known as function composition, or simply composition. That sounded a little weird, so I'm going to read it twice. The practice of using a function to build another function is known as function composition, or simply composition. To demonstrate, we consider a specific example, the palindrome checker. This is a great example to spend some time on, because I know this is one of those fizz-buzz type, beginner level, technical interview type questions, checking if something is a palindrome. I encourage you students, whether you're watching this live or you watch this video later, get good at these little checks right now. Don't skip over them. Please take your time with them. It will pay off for you in the end. So, a palindrome can be defined as a word that's spelled the same backwards as forward, like taco cat, kayak, race car, or mom. There are other factors that are sometimes included in the definition of a palindrome. For example, an alternative definition is a palindrome is a sentence or phrase that contains letters in the same order, whether considered from beginning to end to beginning, ignoring punctuation, case, and spaces. We want to write a Boolean function, just talk about Boolean functions, that returns true or false to determine if a word is a palindrome. One way to state the palindrome condition is to say that a palindrome is a string that is equal to its reverse. So again, mom, dad, taco cat. The string itself is equal to its reverse. Remember that. In other words, we can test for palindromes by taking a string, reversing it, and comparing the reverse string to the original. If the two are equal, we have a palindrome. To that end, it would be very useful to have a function that reversed the string. So if we have a reverse string function, we can drop that in our palindrome check function, and that's the composition that we're going to be going for. Again, to that end, it will be very useful to have a function that reversed a string. Reverse function. Let's write a function that given a given string returns its reverse. One approach uses the accumulator pattern. We like the accumulator pattern. Can we do the accumulator pattern live? Borrow or rob is my favorite Memphis palindrome. Ha! Isaac, I can't handle you. Look, I just dropped a viewer. So, we are, you're wild. Love that guy. Memphis is in the house. Reversing. So we're going to take reversing, and they want to say, can we use the accumulator pattern? So what would that look like? So you'd have a function name or a function keyword. We'd have the function name, something like reverse string. What would be next? We're going to do this from scratch, best we can. What would be next? We have to take in some sort of a parameter, and I'm just going to call it the string. Why not? They suggested using the accumulator pattern. The way I like to describe the accumulator pattern is you start with an empty bucket, you do some iteration, and as you iterate based on conditions, you add to the bucket until you get a final thing. That's how I describe the accumulator pattern. So I want to put reversed string. That looks a lot like my function name. It'll work. That's just really cool. I mean, really close. So let flipped string equal an empty string. Okay. Now we need to do some iteration. How are we going to iterate through our string input? What is the basic pattern that we learned so far? There's more than one way to do it. Well, what's the most basic pattern? If this was an exercise at the end of the chapter and it said you need to iterate through the input string, which we're calling the string, what would you do? Call Lawrence. Good answer. No. You would say we need a counter, so I'm going to call it I. I'm going to start at what? Now, at the beginning of this video, we said we started at 0 when we wanted to start with this guy right here. But what if we start at the end for I equals the string dot length? What if we start at the end and work our way backwards? Let's try that. So for I equals the string dot length, as long as I is greater than 0, we're kind of just doing this on the fly. See what happens. And instead of I plus plus to add on, we want to decrease from our index I minus minus. So as we iterate, we want to take each character we grab. So the first time we start with the last one, which is the G, we want to add it to our empty string, add it to our empty bucket. And so that will be our accumulator pattern. So flipped string dot, is it push? Is it add? Pop? It's not pop. What is it? What's our method? And this is where you want to really, this is so live. JavaScript, add to string. This is what you do. Concat, dot concat, really? That adds 2 strings. Is that what I really want to do? Concat the new string? Maybe. Let's give it a shot. Do I have any input here? Borrow, rob, nope. So flip.string concat what we have, which will be the string at I position. And then we want to return flipped string. No idea if this will work or not, but we'll find out in a moment. So let's call our function reverse. Actually, no, we don't want to return flip string. We need to return a Boolean. Isn't that right? Flip string, okay, yeah. Return, so we need to return the original string, which is the string, is exactly equal to its reversed flip string. And that'll be the Boolean. So now we can reverse string. Let's do a really easy one like mom that we know should give us a return value of true. Mom's not defined. That was weird. Oh, it's a string. Need quotation marks. Put mom in quotation marks. Let's run it again. False. So we're missing something. I equals string.length. Should be -1 for the last index. Run it again. Still false. I minus minus. Greater than or equal to 0 to capture the first one. Still false. Okay, we're struggling. We're struggling now. It's official. I equal to string.length. I greater than or equal to 0. I minus minus. String.length. So the length is 1, 2. Let's just say it was this one. 1, 2, 3. Length minus 3 minus 1 would be 2. So it grabs the m. Go all the way till you get to 0, which would be that index. Let's see what they offer. That was an attempt. This is their approach for the accumulator pattern. Looks like a lot less typing, so I'm going to go with that one. Plus, I bet it works. So we'll copy that. We'll paste it right here. Let's look at their version. Reverse to string, reverse blank string here for I equals 0 to string length. Reversed equals, oh. So they use the plus for concatenation and start with 0. Oh, the way it adds it is, okay, got it. So if the string is, whatever, I was thinking about whipped cream for some reason. So if the string was dole, it'll take the D, the first iteration will take the D, then it'll come back and it'll take the O and add to that. Then it'll add the L to that, then it'll add the E to that, and it's reversed. Got it. Which means in our version, which for some reason is way more complicated than their version, it would be the other way. So just I equals 0, I less than the string dot length, I plus plus. See, does that work? Run. Still, what's different? I can do reversed is reversed plus string, string plus reversed. Interesting. All right, we're going to go with their version. That is okay. We've done our experimenting. I don't want to get stuck on this page. So that does not do anything because we have not called the function yet, but they took the string, start with an empty string to add to it over the accumulator pattern. We did our iteration starting at 0. This is the string concatenation right here, and return the final result. Now we're going to take this and add it to something else. That'll be our composition they're talking about. Same algorithm we used previously to reverse a string. Another approach is to use the fact there is a reverse method for arrays, and that the method split and join allow us to go from a string to an array and back. So they're going back to some of these earlier examples that we had. So here's a nice one. Reversing the string, let the letters of array be that string split, and then the reversed array will simply use the reverse method and do the work for us. Then we can return that thing, join them back on that thing that we split it on, that blank, that space, and we're good to go. Let's break down the steps carried out by this function. I just did that. All right, one more time. Number 1, turn the string into an array of characters. We call this string.split. That turns the string into an array of characters. Reverse them. All they used was the reverse method, right? It's built into JavaScript. Join those reverse characters back into a string using the join, and we're good to go. Try it. Use the method chain to reduce the reverse function to a single line. Open the link below the source code above to give it a shot. And I apologize, I'm a little distracted. There's slight messages flying all over the place, but I don't think it's any of you. So I will get to them shortly. Yep. I will get to them shortly. That's a promise. All right. So that is what they did right there. Turn the string to an array of characters, reverse that array of characters, then join the reversed array back into a string. So that being said, we can look at it is palindrome function. that will make use of the reverse function. So using our reverse function for strings, we can create our palindrome checker. Recall that our approach will be to take the string argument, reverse it, and then compare it, the reverse string, to the original string, which we have right here. And so function reverse does the reversing for us. And so we can embed that function right here in our palindrome function and call it and return whether or not the result from that is the exact same as the original string. So we can use either version. Let's just go with, which one do you guys like? Let's go with this one. This was closer to what I was trying to do unsuccessfully just a moment ago. Reversing a string. And we don't need that .concat anymore. So reversing the string. And we have the palindrome function here, which means what we want to do is to call, oh, did I copy that wrong? No, that's good. We can call isPalindrome. And again, let's try a super simple one like mom. My mom came over for the holidays, fed them good. Mom and dad fed them good, so that's why I got mom on the brain. True, awesome. We can go with cat, expect to get a false. Awesome. And we can go with taco cat. And we get a true again. Again, isPalindrome, using this composition way of putting the functions together, is going to be a function that itself invokes the function reverse. So this becomes like a tool inside our palindrome function, and it returns whether or not the two results are equal, and that is a Boolean function itself. So that's pretty cool. That is palindrome function. Does it work? Run it yourself and see. Yes, it does work. We take a second to check for questions. You forgot the let to. Got the let to. Okay, that must have been earlier. Thank you, Isaac. That must have been let to. Maybe I can move. What can I move? I need to move this where I can see you guys better. Move y'all down here. Nope, that didn't work. Timeout. Quick timeout. I need to be able to see my stream better. All right, there. Good, 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 good. But are you seeing the wrong thing now? You are seeing the wrong thing now. Oh. Ah, there we go. Oh my goodness. We're going to get this together. That there. Move that there. Move that there. Boom. Good. 10.8.2. Hope you're still with me. Functions should do exactly one thing. An important consideration when writing a function is size. By size, we mean functions should be short and, more importantly, do exactly one thing. Principle is easier to state than to put into practice. For example, what if we had written isPalindrome without breaking the reverse code into a separate function? So function isPalindrome takes in a string, let reversed equals that line of code right there, return reversed exactly equal to str. The function is still short, but does it do one thing or multiple things? This is a bit subjective, and here the answer is clearly debatable. More messages in Slack. All right. And not the ones that I want. This function is still short. We already said that. Some cases will be much more clear cut, however. Consider the sandwich function. We talked about sandwich function earlier. Make sandwich from the section. A good function writing process. Suppose we wanted it to expand the capability of our program to not only make a sandwich, but also to pour a beverage to go along with our lunch. It would be a bad idea to amend our function to do so. To do both, ending up with a function that has a name like make sandwich and pour a drink. A better solution would look like this. Now let's just pull that out and just put it in our replit. Not necessarily to run it, but just to see it in replit. So this saying the better solution would be to have, did I copy everything right? Nope. Working on my copy skills. They're saying the better solution here would be to have a function called make lunch that itself invokes the sandwich and drinking making functions. So calling make lunch with its parameters first calls the make sandwich function with its parameters, then it calls or invokes the pour drink. So this is a lot more easy to read. It stays with the convention of having the function do only one thing. Our program is happy. And our fellow programmers are happy as well. Why is this better? Smaller functions are easier to debug for one thing, and by separating single responsibilities into individual functions, we also make our code easier to read and more usable. And I'll just go ahead and say this general idea is kind of what gave birth to the idea of microservices, where instead of having everything always being infinitely long, seemingly infinitely long monolith programs, can we pull out chunks of code that may still be long in themselves, but they achieve one larger purpose, and package those and have those communicating with other services, each one that be a lot easier to debug. When you get error messages, when you get alerts, when you get calls at 2 in the morning and you're on call as a programmer, it'll be a lot easier to pinpoint what part of the code do I need to go to, as opposed to having one long monolith. Not always a solution, but that's generally the idea that they're going for here. It applies to functions as well as entire code bases itself. 10.9, why create functions? Let me check for any questions. No questions. Still have 3 viewers. Slack is still going off, but it's not you guys, so I'm going to keep it moving. 10.9, why create functions in the first place? Great question. After wading through all the new syntax necessary to create a function, you might be asking yourself, why would I ever want to do this? Good question. They reduce repetition. This helps us keep our code dry, D-R-Y, do not repeat yourself. When we need to repeat the same basic task in multiple parts of a program, the function will allow you to package that up into a task into a neat, reusable form. Loops will enable the same task to be repeated many times in succession, while functions enable the same task to be repeated in different portions of a program. That was a little key sentence. I'm going to say it one again. Loops enable the same task to be repeated many times in succession, the same task. Functions enable the same task to be repeated in different portions of a program, because all you have to do is invoke that function. 10.9.2, functions make your code more readable. Placing a piece of functionality in a function allows us to make a name, put a name on the functionality. Consider our palindrome example. One way to write that function is function palindrome, taking in a string, let reversed equals that empty string. For, we have our iteration statement. We have our reverse statement, where reverse is going to equal the original string at that index plus the reverse string, our new string we made. And then we return whether or not reversed is the same as string. While the variable name reversed is descriptive, giving us a sense of what's going on with a for loop, the function becomes more readable when we break out the reversing behavior into a separate function. And hopefully you can see this on my screen, but you should be following along in Canvas anyway. So we like this second version a little better. Let me put my cursor in the right place. We like this second version a little better because we have the function is palindrome, refers to and invokes the reversed function here. All right. And hold on. Yeah, it looks like we return. This is interesting. So yeah, the reverse returns the reversed. The is palindrome only returns whether or not it's true, which is what we love, the separation of concerns. This one tries to do, or it does, all of those two things all in one. And that's not what we like in terms of convention. So that's why we like this one better. This version down here, the second version, the function called is palindrome, all it does is check, is it a palindrome, via that line. The function reversed creates the reverse string for us via these lines right here. So that's why we like the second one better. And I did not realize how much of the screen is not visible to you guys. Let me see, is this, that is way off the screen. Interesting. I could reduce the size of my big head, but let's just keep it moving. Large programs can be broken down into smaller parts using functions. Imagine a car built out of a single large piece of metal. Were such a car to break down, diagnosing the problem would be difficult. Fixing it, nearly impossible. The mechanic would have to determine where the issue was, cut apart the bad portion, create a custom-made replacement, weld it into place. The complexity becomes much less when a car is made up of a lot of small parts, each of which can be tested and replaced individually, and the same thing happens with code. 10.9.4, functions enable code sharing. Encapsulating behavior, putting behavior inside a function, makes it easy to reuse that code within a program. but it also allows you to share that behavior across files. We'll definitely see this. I think we'll see this some in JavaScript, but we'll definitely see this in our Java section. Having a function that does a series of steps, and we need those steps to happen in some completely different file. Functions help to enable that functionality. This becomes critically important when you start to work on bigger programs that consist of a large number of files, such as your next dev job. You'll explore this idea in the modules chapter. 295, functions save millions of lives every day. Okay, not really, but the point is functions are incredibly powerful tools that you will come to appreciate and find indispensable. Ask any professional programmer if they can do their job without functions. The answer will be an emphatic no. And that brings us to the exercises. I am not doing the exercises live. I want you guys to do those and to reach out to me on Slack where you get stuck. Got here a little faster than I expected, so let's add that all up. I started tonight at 7:15. We're going until 8:36, so about an hour and 15 minutes, hour 20 minutes. We did 2.5 hours last week, so that's 3 hours and 45 minutes. That's how long it took to go from the beginning to the end of the chapter, coding literally every single example, which means I'm at a point right now, and you at a point as a student should be at a point where you're very comfortable with material. And as I wrap this up, again, thanks for showing up tonight. Any questions about the lecture, any questions about the video, just drop them in the comments or hit me up on Slack. But the biggest thing about tonight was just re-emphasizing, for hopefully the last time, the importance of active reading when we're going through these chapters, taking the examples, putting them in Replit. Sometimes it'll work. I had one tonight that completely didn't work. I completely messed up the reverse string. Try to go through these screens, and who knows, maybe I just forgot the pattern. But that's all part of the process. And at the end of the chapter, if you do this method, you will find yourself a whole lot more comfortable with material. So that being said, I'm going to wrap things up. Appreciate you coming out this evening. Amazing teaching, good work. Thank you, Isaac. Appreciate that very much. Y'all have a great night, and I'll see you next time.